guys, today we are going to talk in a little bit more detail about molar mass. We had a little bit of an introduction to molar mass in our mole notes, and then you guys worked through that POGL. So now I want to give us kind of a formal definition and some practice. Last time we said that molar mass is the mass of a substance in 1 mole of that substance. The molar mass, which is grams per mole of an element, can be found on the periodic table. So now we want to talk about using molar mass. How do we calculate molar mass? The best way to go about this, in my opinion, is to just work through an example. So in this example, we want to know the mass of 1 mole, so that's the molar mass, of the molecule glucose, which is C6H12O6. You can see the structure on the right hand of the screen. It's not super important, it's just interesting. Anyway, here's the plan. The first thing we need to do is find the molar mass of each individual element on the periodic table. So find the mass for carbon, find the mass for hydrogen, and find the mass for oxygen. Second, we're going to calculate the mass contributed by each type of element based on how many there are. So there's 6 carbon, and so we'll have to do 6 times the molar mass of carbon to find out how much mass it's contributing. Third, we're going to add all of those masses together to find the total molar mass of glucose. All right, let's get started. Step 1, molar mass. Identification. Molar mass of carbon is 12 grams per mole. I found that on my best friend, the periodic table. The molar mass of an individual hydrogen is 1.01, and the molar mass of an individual oxygen is 16 grams per mole. So now that we have the molar masses of the individual elements, we're ready to move on to the next step. So we need to find the mass of 6 carbons, since we know there's 6 carbons in a glucose molecule. So we can do 6 times the molar mass of carbon, which we found to be 12.01 grams per mole. And that gives us that carbon contributes 72.06 grams per mole. We do the same with oxygen. There's 6 oxygens. And so the molar mass of oxygen is 16. 6 times 16 gives us 96 grams per mole from oxygen. And then the mass of hydrogen was 1.01. We have 12 hydrogens, and so when we multiply that together, we get that hydrogen contributes 12.121 grams per mole. Now that we know the individual contributions, we can put it all together by adding them up. So, sorry, I'm being attacked by a dog. We have 72.06 from the carbon plus 96 from the oxygen plus 12.12 grams per mole from the hydrogen, which gives us 180.18 grams per mole. So the molar mass is 180.18. The other way you could write it is you could say the mass of 1 mole of glucose is 180.18 grams. And so notice the only difference there is the unit. Okay, now that we've walked through this, I want you guys to try to do 3 simple examples in your notes. You should pause the video, try these on your own, and then on the next slide, I'm going to just show you the solutions briefly. Okay. So the molar mass of water, there's 2 hydrogens, so molar mass of hydrogen times 2 plus molar mass of 1 oxygen gives us 18.02 grams per mole. For carbon dioxide, 1 carbon is 12.01 plus 2 oxygens, so 2 times 16. Add that together, you get 44.01 grams per mole. And finally, for phosphoric acid, we have 3 hydrogens plus a phosphorus plus 4 oxygens. And when we multiply that out and add it up, we get 98 grams per mole. I can leave that alone. Oh, no, that's not for you. Okay. So hopefully these are pretty straightforward for you. What are you doing? So then, once we can calculate molar mass, we want to focus on how we can use it to find things out about different chemical species. So in this first example, we're going to look at how many moles of C2H6 are in 105.28 grams of C2H6. And so our plan for this is to find the molar mass of C2H6. That's always a great place to start anytime you're doing a problem, is just, go ahead and find the molar mass. And then the second thing we're going to do is use the molar mass and our factor label method to convert grams to moles. See, factor label is going to be useful. I wasn't just torturing you for fun, although, that was like an added bonus. All right, so let's set it up. First part, molar mass. 2 carbons plus 6 hydrogens gives us 30.08 grams per mole for this molecule. Then part 2, use the molar mass and the factor label method to convert grams to moles. So I'm going to take the amount they're asking me about, which is 105.28 grams of C2H6. Notice that I labeled the identity of the substance. This is going to become really, really important. So get into the habit of labeling things now. So we took our starting point, and then we want the grams to cancel out. So we're actually going to put the value of the molar mass on the bottom of our factor label line. So we've got 30.08 grams on the bottom, and then 1 mole on the top. Now our grams cancel out, and we're left with moles, which is perfect. When you divide it out, you get 3.51 moles of C2H6. Next example, what is the mass of 1.68 moles of iron chloride, specifically iron 3 chloride? Same plan, find the molar mass of iron 3 chloride, then use that molar mass and factor label to convert moles to grams. So the last problem, we went grams to moles. This time we're going to go moles to grams. First step is the same. 1 iron plus 3 chlorines gives us 162.2 grams per mole. Once we have that molar mass, we can set up our factor label line. 1.68 moles of iron 3 chloride over 1 mole of iron 3 chloride and 162.2 grams of iron 3 chloride on the top. So we're just using our molar mass as a conversion factor to get from moles into grams. And we see that our moles cancel out, our grams are left behind, and that gives us 272.5 grams of iron chloride. Okay, now it's your turn. 3 practice problems going from moles to grams. Grams to moles, and from grams to molecules. Okay, so that last one is a little different, but you can do it. We talked about how to get from moles to molecules. So if you can get from grams to moles, you should have all the conversion factors that you need. Take a peek back at our introductory mole notes if you get stuck. Go ahead and try these on your own in your notebook. The solutions are on the next slide. Okay, so we want to know moles of sodium sulfate in 383.54 grams of sodium sulfate. First thing I'm going to do is find my molar mass. The molar mass of sodium sulfate is 142.0 grams per mole. Now I can plug that into my factor label line. So I'm starting with my given amount, which is 383.54 grams of sodium sulfate. Then I'm using my molar mass that I calculated on the bottom so that the grams cancel out, and I have 1 mole on top. So this gives me 2.70 moles of sodium sulfate. Next problem says, what is the mass of 0.075 moles of magnesium bromide? So I'll start with my given, which is 0.075 moles of magnesium bromide. I want my moles to cancel out. So when I calculate my molar mass, I'm going to put the grams on top and the 1 mole on the bottom. Magnesium plus 2 bromines gives me 184.11 grams per mole. So I plug in that conversion factor. When I math it out, I get 13.81 grams of magnesium bromide. Okay, last problem. This was our little bit of a challenge problem. So we're starting with 309.21 grams of potassium phosphite. And we want to know how many molecules of potassium phosphite are in that mass. So we'll start with our given 309.21 grams of potassium phosphite. I need to get to moles if I'm going to get to molecules. So I'm going to use my molar mass to get to moles. I want my grams to cancel out, so I'm going to put the molar mass on the bottom. So 196.27 grams. I just added those up from the periodic table. That goes on the bottom, and the 1 mole goes on the top. Now our grams cancel out, and we're in moles. I need to be in molecules, though, so I'm going to recall the relationship that 1 mole of any substance is equal to Avogadro's number of that substance. So 1 mole of potassium phosphate is equal to 6.022 times 10 to the 23 molecules of potassium phosphite. Now my moles cancel out, and molecules is all that's left on top of the factor label line. And so this is really good. We're at our target unit. Now we just have to do the math. Multiply the top together, divide by the bottom, and we should get 9.49 times 10 to the 23rd molecules of potassium phosphite. To practice some of our skills around molar mass, we are going to do a lab. Unfortunately, we can't really do the lab. And so what I've done is create some data for you. So I'll be walking you guys through that lab. And so that'll be the next video.